Good evening, ladies and gentlemen. Today we are going to be doing fractions. Remember, the aim is to help you with your mathematical discourse. So then you know when you are reading a specific chapter or any topic, what kind of mode of thinking that you have to put in when you are dealing with this mathematics. And then remember, your course is the most difficult one because it's looking at the basic numerical skills. It's not like people who are doing aboma calculus, aboma financial maths, because that's more of your application. With you, it's all about my basics. But once you understand, I mean, you can imagine someone who is trying to learn new language. Let's say, Mina, I'm a Xhosa, so I'm trying to learn Isivenda. It's difficult because I need to start from basics. But from someone who already knows some of the basics to learn other deeper ways of speaking in Venda, it's going to be easy for them. So for us, it is difficult because we are looking at little yana things, and those little yana things you can even get the answers with calculator. And I'm sure if ever you've got your children, your son or your daughter, they will ask you, "Guti mama mara, why are you bothering not using a calculator?" It's because the nature of your course, you need to be able to understand the basic numerical skills without using a calculator. You can use a calculator just to confirm what you got the correct answer. Okay, so now I'm going to help you to develop, or we are going to be working on fractions. Fractions, they seem easy. Yes, if you are going to use a calculator, it is easy. However, with us, we need to understand the basic knowledge, the basic discourse about the fractions. We need to understand the words that are being used. What are the different names? Remember, we said, look, and another thing that I'm trying to do is to build some kind of love of mathematics. Once you speak passionately about a thing, you fall in love with it. Okay, so that's one of my aims. It's not necessarily to help you with the content on or how you can study it. It's also to feel the passion. Once you feel the passion, even if it's a topic that you find difficult, you find it that you can negotiate with it because you are in love with it. So now we need to understand, Guti, take a fraction as if it is this big person, and then this big person has got many children, and then these many children have got different names. You understand? Think of it like that. So hence we need to know, good, okay, once we are talking about a fraction, what is a fraction? A fraction is something that has got, it's a number that's got a numerator and a denominator. That's what we mean when we talk about fraction. And then it can take different forms. You understand? It can be an improper fraction, it can be a mixed fraction, it can be a proper fraction, it can be what? A fraction can also be in a decimal form. You understand? So what you are trying to do here is to say, how do you speak about this big? This big, is it? He looks like a man, France something, whatever she is or he is, but he's this person who's got many children. So remember, this is mathematics. Every topics there are operations. Those who were here with me on Wednesday, remember we've spoken about operations. Operations is positive, negative, multiplication, and divisions. Those are the building blocks of mathematics. You need them. They are connecting everything together. So you also need to remember the laws of operations or commutative law. All those laws, remember them, bring them to your memory. You have to know how you are going to integrate them. And then I'm going to take you through how we can think around fractions, how we calculate them. Okay. And then remember, I said, if you need to consult with me, please do that. But before you come to me, I would like you to have a journal. In that journal, you can have an old diary. I mean, I'm no longer using a diary, but I think you can get a diary now just for your thinking of mathematics, whereby you are going to have a topic and say, okay, this is a topic that I'm studying today. What is it that I need to know? The object of learning. Then you are going to have a heading, object of learning. So the object of learning, where do you get it from? You get it from your chapter. At the beginning of the chapter, there is a what we call learning outcomes. Your learning outcomes are what you are expected to learn. It's an object of learning because you are not expected to learn everything about fractions. This is a little bit that you are expected to know because all of the assessments are aligned to these objects of learning. So now one of the objects of learning is to identify abantwana, different children of fraction. You need to be able to identify who is proper, who is called proper fraction, who is called improper fraction, who is called mixed fraction, who is called equivalent fraction, what is a reciprocal of a fraction. Those are the different ways that we find in fractions. Okay, and then we are going to also do what we call the routines. What is it that we do with these fractions? We simplify them. The different ways of simplifying fractions, one will be to break down the fraction into its equivalent form, into the equivalent fraction. One is to do a prime factorization. One is to find a greatest common factor. One is to add, one is to subtract, one is to multiply. I will take you through. Those are the routines. We call them in mathematics repetitive actions, something that you need to do about fractions. So now we are going to be reducing these fractions to their lowest terms, divide and multiply. Can you see where the operations are coming in? You need operations, and the rules of the operations, you need to be aware of them. You need to determine the place value in decimal. We are going to be doing decimal numbers, and then write a decimal number as a fraction, and then write a fraction as a decimal number, and then round numbers. Like when they say round a number to the second decimal place or to the third decimal place, and so on and so on. No, it's not I must not say and so on and so on. This is all that you need to know. Because when I'm saying and so on, I am suggesting that there are other things that you need to know which are outside of what you're expected to know. Why it's important for you to know what you're expected to learn is because we are not using one resource. Maybe you can find yourself you are using a textbook from whatever textbook that you would be using, which is different from what is prescribed. There are many objects of learning. So you don't want to be learning everything that you're not even expected to know. So make sure that you know exactly what you are supposed. So then you can be able remember, you're not only doing this course, you are doing other courses. So you need to be very economic with your time. Okay, this is what you're supposed to know about fractions, né? Only about fractions. And then remember, after that, we are saying what is it that is critical for you to learn about fractions. Okay, you can write yourself a mind map. I always love mind maps. I'm busy designing mind maps for the basis because I'm working with grade 7s. So I'm going to be having a website whereby I'm going to be sharing mind maps for anything. If ever you've got fractions, that is a concept map of anything that to do with fractions. So I think that is going to be helpful for you going forward. But what I can suggest for you to do right now, do a concept mapping. Okay, a concept mapping, you can get it from, go to Google and say mind mapping. Just look for any template for a mind map. So then you can do your mind map. Mina, I don't like to do my mind map online because I get creative when I'm using my hands. So I like to play around with my hands and write things down. I get very productive when I'm writing. So if you don't like writing, do a mind map online. So then it helps you to remember, okay, when I'm talking about fractions, I know these are mixed fractions, like fractions, proper fractions, improper fractions. So this is a mind map that I got somewhere from from Google. So at least it helps you to understand the critical aspects that are related to ilento ama fractions. So now I'm going to pull a little bit on what are the misconceptions that you find when you are working with ama fractions. The critical ama misconceptions is one to do with addition, or whereby you have to add an improper fraction to a mixed fraction. I'm going to be highlighting these as we are going along. I did not write them down because I saw that there are many of them. So I'll be taking you through your notes so then I can help you to unblock any misconceptions that you might have. So then things can become easy for you when you are studying. Remember, we are studying on our own, so we need to make us our own projects. You become your own project. So then you ask yourself, what is it that is difficult on this topic? So once you have identified what is it that you think is difficult, you can always you can ask for help. Otherwise, you cannot just say, ma'am, I don't understand ama fractions. I don't know what is it that you don't understand about ama fractions. So I would like you to write a journal. Okay, so here's another example of a mind map. I also got this from Milento from Google. It just gives you a mapping. What is this family Yaboma fractions? What does it look like? What are the things that are unique about this one? So it is good to have a mind maps. You don't need to write them. You can go and Google them. If ever you're doing a certain topic, have a mind map of a specific thing. Just enter it on Google search. You will get it. So then it helps you to do a revision on conceptual understanding of this concept. Okay, and then here's another one which I have found so beautiful. It's more like a Bible. This one is something that you can do to confirm if ever you got things right. You don't need to use a calculator, but it is a way of saying there are other ways. I'm a shortcuts. Remember, we're doing mathematics here. After we've understanding the concepts, how we do our concepts, there are shorter ways of doing this. Okay, so here we are saying, let's start with this one of a subtraction. What we are saying, you've got 2 over 3 minus 1 over 2. So just to get this thing by inspection, in there, you are saying, you're starting from 2, you're saying 2 multiplied by 2 is 4 minus 3. So you're going to get 1. Then you just multiply your denominator, then you've got 1 over 6. You can fight for any fraction. You will always get here without going through all the steps just for checking. Ne? Here, you've got 3 multiplied by 1 plus 2 multiplied by 1, which is equal to 5. Okay, then you multiply your denominators, which is going to be 6. So here is your answer. With the multiplication, you multiply your numerator, which is going to be equal to 3. You multiply your denominator, which is going to be equal to 10. So there is your, these are the shortcuts. Sometimes they work. Sometimes they don't work if ever you've got a complicated numbers, big numbers. This is just when you're doing simply numbers are simply just want to check if ever you are on the right track. Here is for division. I will take you through on how you move from here to multiplication. We talk about the reciprocal, whereby division we said is a reciprocal of a multiplication, and multiplication the reciprocal of a division. So I'll take you through on how you do this thing, but this is more like a roadmap on the shortcuts, methods, lento. So you've got this one, which you've got a mixed fraction. So here you add, I'll take you through this. You add the whole numbers. You've got 2 minus 1, which is equal to 1. And then you take the fractions. You take the fractions and then you deal with fractions. I will take you through this on how you get this in, but I'm going to post this thing for you so then you can have those kind of shortcuts in case you are lazy to calculate or you want to test if ever you got the correct answer. Here, Also, this is a mixed fraction. I will take you through on how you get the answer. Here is also the mixed fraction. I'll also take you through on how you get those. Okay, so what I want to do today. Okay, I'm working from your notes. Yes. Because what I saw, yes, it's not about getting the right answers. I just wanted to take you through on how you can study this and then highlight the misconceptions that are possible. Okay, so here, this is your object of learning. I call this one an object of learning. This is an object of learning. What is it that you are expected to know according to the AMA PowerPoint slide? I've already taken you through this. So remember, we said I am going to take you through on the concept mapping, the building your conceptual understanding. You've got different families of AMA fractions. Fractions, we always see it by this. You've got a denominator and the numerator. A proper fraction will be the one whereby your numerator is smaller than your denominator. Okay, I'm not going to be using this example, but I used to use this example, and then somebody called me and said, hey, this is a very sensitive thing that you are saying, blah, 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 blah. I used to, I'm an African, Mina. There are ways that we are being described, Tina, as women. Here in Africa, they said, "Hi, you must have you must have small breast, and then the figure, and then you've got big. You must be big, like Aboma Kardashians. That what they are doing right now. They've got big bums, and then they are smaller at the top. So that you can view it as a proper fraction." Whereby your numerator is small and then your denominator is big. That's a quick way of remembering that. And improper probably could be the men lababa jimayo, those who've got a boma six pack. They are big on top, they are small as so that is an improper fraction. And also, if ever you've got the same numerator and the same denominator, that is also improper. But I'm not comfortable with the word because this is just equal to 1. But let us go with what is written here on the notes. And improper is when your numerator is bigger than your denominator. And then your mixed fraction is the one which is looking like this. You've got a whole number and a fraction. And then you've got an equivalent fraction. And equivalent fraction is when you've got 4/6. Equivalent fraction is this one. If ever you were to divide, that's how we will describe it. We will say it's an equivalent. If you divide by 2 and divide by 2, you're dividing by the same number on numerator and your denominator. This is going to give you 2/3, and then this one becomes an equivalent fraction of this one. Because why is equivalent? It's because you have divided by the same a factor on numerator and your denominator, and then you get a product of that, a quotient of that. So that becomes an equivalent fraction. If you want to go back, if you were to multiply this by 2 and multiply this by 2, you would go back here. So they become, they represent the same number. It's almost the same. It's just that there's a common factor. Okay, and then there's a reciprocal. A reciprocal is simply if ever you've got 1 over 10, and then this is going to be equal to 10, 2/3. A reciprocal of 2/3, it is 3/2. What does it mean? It simply means you just flip. You just flip whatever your fraction, your numerator becomes your denominator, and your denominator becomes your numerator. That's how we define ilento. We define a reciprocal. And another name of a reciprocal, it is called the multiplicative inverse. Okay, I'm highlighting the words. Remember the mathematical discourse. The mathematical discourse is for us to understand the different names of naming one thing. So then when you get a question, they are talking about multiplicative inverse. You must know what they are referring to, the reciprocal. There's too much language. You know, yesterday I was writing a paper. I was talking about the decolonialization of mathematics. And then I was very upset when I was reading one of the articles. It made me upset actually because the guy was speaking the truth. Uguti, we are here, Tina, as Africans, We used to have our own ways of doing things. We used to have kettles. We used to calculate our kettles. We had our own special ways of calculating kettles. We knew how many males are in my crawl. You know, we had a very own way of calculating even the sun. What we know when the sun is at the specific position, what is going to be happening. We even had our own geography. But that kind of knowledge, when the Europeans came, they just ignored that kind of knowledge. And then they brought in, especially in mathematics, they brought in their theorems, which have got too many rules, too many properties, too many names. And then Tina, we are just left out there. We are supposed to be learning these things. That's why we are having problem with mathematics. Maybe perhaps our ancestors are coming back and saying, we don't want this thing, because we always struggle with these words. I mean, you've got a reciprocal, and then they show you how you write a reciprocal in a symbolic form, and then there's also this name is also a multiplicative inverse. There are many things, Tina, that we need to work with before we can even converse mathematically. So if ever you can start to talk about politics of mathematics, you can be very upset and just leave the subject. So I just need to make peace with myself and negotiate that kind of a knowledge, because I need to know what was the colonialization, how we were colonized in the mathematics space, and then try to see if ever we cannot find ways of resolving that, if we are going to be able anyway. So what I'm trying to say to you, you must not be upset with yourself if ever you are struggling to remember all of these things. It is not our language. It is something that came, and then with so many keywords that you need to understand. Okay, so now this is the family of fractions, and then remember, this is the definition of fractions. Is when you've got a numerator and a denominator. I did not see any issues there. I have gone through your notes so then I can pick up any critical aspects. That is the aim, is for me to pick up the critical aspects to help you to study this. So remember, we said the proper fraction is when the numerator is bigger than the the denominator. That is a proper fraction. There is nothing much that I've identified that is going to be a problem to you, other than understanding these to be able for you to be able to identify them. Improper fractions is when your denominator is smaller than your numerator. You've got a mixed fraction. This is how the mixed fraction is. When you are working with mixed fractions, okay, it is important to convert the mixed fractions into an improper fraction, because you cannot really do calculations with this. Simply, what you do here, you start with your denominator, you multiply it with this whole number, and then you add your numerator. Okay, so you're going to have 3 multiplied by 3, that is equal to 9 plus 1, which is going to be equal to 10 over 3. You write that same proper fraction, improper fraction, and then here you are going to have 9 multiplied by 7. I don't know what is 9 multiplied by 7. 9 multiplied by 7 is 63 plus 3, that is equal to 66. So this one is equal to 66 over 7. Even this one, we're going to have 8. 8 multiplied by 1 is 8 plus 7. So 8 plus 7 is equal to 15. So you're going to have here, you're going to have 15 over 8. So now always remember, when you're working with a mixed fraction, you have to convert it into improper fraction. Okay. So now that's that's all what they mean here. This is just a process. Okay. We can do this thing with our calculators, guys. A calculator can calculate for you the mixed fraction and give you an answer. But remember, now you are at that level whereby you need to be doing this thing by manually. Ne? So we are very sorry for that. Okay. So this one, this is just an example that I've shown you. So here, without going through step by step, okay, You must not be intimidated by all these steps and think, ooh, lento is difficult. You can do this thing by inspection. 45 multiplied by 4, which is 20. 20 plus 3, it is just equal to 23 over 4. Okay, without going through this step, because this thing, for me, when I looked at it, it intimidated me. Go to show, what is this? I thought it was a different method. It's just that they're trying to show you step by step on how you get this. But you can just, from here, do this thing by inspection. You're just putting your mind, you're exercising your brain cells without writing things down. There's too much in mathematics. You cannot be writing everything down. Some of the things you can just do them by inspection. Just inspect it, look at it, and then get an answer. As long as you understand, you've got a template. Okay, if you've got an instruction, this is what you do. Okay, and then improper fractions to a mixed fraction. Simply, without going here, you are going to have 13 minus 3, and then to a mixed fraction. If you can remember from esikolweni, this is like doing ilento remainder theorem. Okay, remember remainder theorem. This is what it means. Okay, we are saying 3 goes how many times to 1 to 13, or 3 to 13 we are 4. Then you are going to say 3 multiplied by 4, this is equal to 12 over this minus, this is going to be equal to 1. So this becomes your remainder. So how you write this? How you write this, you are going to have 3. You're going to have 4, because now 3 uyakangaki ku 13 uyakai 4, and then your remainder is 1 over your numerator there, which is equal to 3. Okay, so you don't have to do a remainder theorem. You can simply get your answer straight from here. 3 goes how many times to 13? It goes 4 times. And then what are you left with? You are left with 1 over 3. I'm just taking you through if ever you are struggling to understand this. And remember, we are not on same levels. Okay, some of us did mathematics 20 years ago or 10 years ago. So we are just trying to remember these things. So it's difficult to learn these things on your own. So it's always easy when we are talking about this thing. That's why we are having a mathematical discussion or a mathematical discourse. Okay, it's not as if we've never seen these things before. We've seen them before. We are just trying to remind ourselves. Okay, so now change the improper fraction to a mixed fraction. Same thing, 7. 2 goes to 7. How many times? It goes 3 times, and then you'll be left with 1. So you've got 1 over 2. You're taking the similar denominator there. You can just do that by inspection without really going through these steps. These steps look so they're intimidating. Okay, you can find yourself, oh, this is intimidating. So what is happening here? Okay, this thing is, you can move from improper to mixed, from mixed to improper. So these two processes, they are working hand in hand. You move from left to right, right to left. Okay, like here, you are 5 divided by 3, you can get it into a mixed fraction. You can also move from mixed fraction back. So this is just a process. Okay, so I don't foresee any misconceptions that could be building here, other than remember how we do this. Don't let these calculations intimidate you. I think this chapter was well done and well articulated. It's in a very most simplified form. It shouldn't really intimidate you or make you have any question, any problems. But I'm going to leave some time whereby you can share with me what are your difficulties or misconceptions, and let's see if ever I cannot attend to them as we are in this class, especially with fractions, because I think I really enjoyed the notes when I was going through the notes. Remember, I did not write the notes. I also needed to learn them also to see what are the things that I think needs to be added. Where are the gaps? Is the information too ambiguous? Or is there a way that we need to break it down? So those are the things that I want to highlight to you, so then you don't get intimidated. Okay, so now remember we said you are writing things. I've shown you how you write this thing in an equivalent form. An equivalent form, we said equivalent form is when you are going to be writing a thing whereby you'll be multiplying a numerator and a denominator with the same number. Okay, so now when you are doing amalento, ama calculations, this is the thing. We always want to simplify in such a way that our denominators becomes similar. Okay, then we always look out for any equivalent forms of the fractions. That is the strategy. Equivalent form is another strategy of solving fractions. Take for an example here. Okay, there are many ways, of course, of solving this thing, but we are not yet doing algebra. You can do this thing using algebra, but we don't want to use the algebra, and we don't even want to cross multiply, because remember, we are not using a calculator. We are using our brains. So we want to simplify any number into its simplest form. So now when you've got this, we want to make sure we've got the similar denominators. Okay, so now our right-hand side is fine. We can leave our right-hand side. This one we'll leave it because it's already complicated, but we can rewrite this one. So then our 3, remember the focus is on your denominator. Rewrite 3, so then it's equal to 24. And ask yourself, which number can I multiply with 3 so then I can get 24? And then you think, oh, is equal to 8. So I'm going to take 8, multiply my numerator and my denominator with that number, only my left-hand side, and put this thing in its equivalent form. So now I am going to multiply my numerator and my denominator by 3. This is also going to be multiplied by 3. So I'm going to have 3a over, you write it, 4, man, you right? 8, askis, 8, ne? 8, because remember your focus is on your denominator. You want to write, you want your denominators to be the same. So you are looking for a number that you can multiply your left hand side, so then izoba ne denominator efanayo with this one. Okay, so now you've got a over 3 is equal to 16 over 24. You only choose left-hand side or your right-hand side. Let's say we decide to choose your left-hand side only. You want to make your denominator of your left-hand side ifane with 24. So you'll multiply in numerator and the denominator with 8. So you're going to have 8a divided by 3 multiplied by 8 is 24, which is equal to 16 over 24. Okay, once you've got this case, okay, if the denominator on your left-hand side is the same as the denominator of your right-hand side, you can drop your denominators and simplify. So here you are going to have 8a is equal to 16. You are allowed to do that, okay? The denominators that are are the same. Left-hand side is equal to your right-hand side on your denominators. You can drop. It's more like you are given a portal. They say a portal. I'm using a language of spirituality. I'm also studying spirituality at the same time. So they are talking about portals. Portals is when you are getting an entry. So now this thing is giving you an entry. You've got 24 on your left-hand side on your denominator, and 24 is only on the denominators, guys. You drop your denominators if they are the same, then you take the numerators. Then you've got 8a. Therefore, now you divide both sides by 8. So this is going to be equal to 2. Let's say I don't like to start with my left-hand side. Is it a crime if ever I decide to work with my right-hand side? It is not a crime at all. You can work from here and say, mina ngifuna uthola an equivalent form of my right-hand side. I want to work with this. Okay, I don't like left-hand side. I mean, who says I cannot work with my right-hand side? No one. You can do it if you think it's going to give you an answer. So here you are going to have 8 you are going to have A over 3 is equal to my pen is unstable. Okay, so here what you say, I want to write my denominator here to be similar to U3. What do I do? For U24 abe equal to 3, it means I need to divide U24 go 8. Okay, 24 divided by 8 in Zotola U3. Whatever I do on my denominator, I must do on the numerator. So now I am allowed to use any of the operations that is multiplication and division when you are doing an equivalent form. So here I'm going to divide by 8. I'm also going to divide by 8. Okay. Sharp. So 16 divided by 8 is going to give me U2. And then 24 divided by 8 is going to give me U3. Okay, the denominators are the same. I can drop the denominators. I've got the portile, negative left-hand side, right-hand side in Tolinte one, so I can drop it and then stick with my numerator. So therefore, my numerator, my A, namhlanje ipeni yami, it is on leave. So now you drop your denominator ke bakwethu. Then you are going to have A, drawing. Okay, what is important, I was talking about the equivalent fractions here. Guti, it's up to you if ever you want to, I'll just point to this one. If you want to work with your left-hand side or your right-hand side, that's really up to you, okay? You can just decide to, okay. You can work with your left-hand side if you like, or you can work with your right-hand side if you like, okay? Here. Anyway, so now let us talk about AMA reciprocals. Remember, we said AMA reciprocal is when we are going to flip a number into its reciprocal form. And then you've got this number 3/4, and then you write it as a reciprocal form. So I'll just highlight 3/4. You write it in this reciprocal form, and then it is that's going to be equal to 1. So if ever you multiply a number with this reciprocal, that's a law. It is going to be equal to 1. And then remember, was it this class whereby I was talking about ilento identities? If ever you multiply A by 1, you get A. If ever you divide to A by A, you're going to get 1. So that is the same language that we are using here. Okay, so okay, I'm not going to emphasize and go back to what we did on linear functions. I'm going to proceed where I left off. I'm even opening a page where I stopped. We're doing quadratic functions. I was at the stage whereby I was trying to take you through on the concept mapping. Every time you're going to be answering a question on quadratic functions, you need to keep in mind what is your toolbox, okay? It is helpful because you know this is quadratic functions, these are the toolbox, and this is how I'm doing things, okay? So remember we said quadratic functions, they are looking like this. They're in this format. And then I was about to explain 3 different forms. I'm still doing a concept mapping. 3 different forms. One form is the one of one which is we are familiar with, is ax squared plus a bx plus c. This is the most one that we see. What is important is, what does this represent? Okay, this represents that the things that you can read. What information is it giving you? Your quadratic form, if ever you've got an equation, if your thing is in equation form, what it suggests is if ever your A is greater than 0, that means if your value of your A is positive, it means you are going to be having a graph which is smiling. We call it a smiling face. My high school students, they call it a smiling face. Your parabola is going to be looking upwards. And then if ever your thing is negative, your thing is going to be frowning. They call it frowning. Okay, that means it is looking downwards. Those are the things that are suggested by your A. So it is important for you to know how to interpret the equation. Okay, so what else does this represent? This represents your C is your y-intercept. I'm trying to develop a concept map here that I can always remember. This will be your concept map. And then what else do you get here? You get that we know in Toguti every time you are working with a parabola, it looks like this. A parabola has what we call axis of symmetry. That means there's that line which is dividing your parabola into half. This is your axis of symmetry. Also, you can get the axis of symmetry if ever you are given a quadratic equation in this form. So the formula for the axis of symmetry is x is equal to let me start with okay, it is x is equal to minus b over 2a. These are the things that you need to remember when you are using this. So now, if ever you've got this, you can get your axis of symmetry. Your axis of symmetry, it means you're getting the x-coordinate, of your turning point. Your axis of symmetry is when your graph is turning. That means where it is turning your turning point, and is specifically giving you the formula for your x-coordinate. So now that x-coordinate can be substituted back to your original equation, so then you can get the y-coordinate, so then you can get the points of your turning point. So this is a formula that you can find for your axis of symmetry that is suggested by this formula. And what else? The x-intercept. The x-intercept is when your graph is cutting your x-axis. Okay. So sometimes you find what we call these the zeros. Okay, when you find a question that is saying find the zeros, you know you are looking for your x-intercepts. So the formula for the x-intercept is the one that is famous, that we always know, minus b plus or minus b squared minus 4ac divided by 2a. This is the formula that you would use when you are trying to solve for your x. So this is divided by 2a. Okay, so this is for your x-intercepts. Okay, for x-intercept, this is what the formula that you would use. So this is what it's suggesting. And then what else does this thing suggest? This thing is suggesting when you look here inside your radical sign, there's this formula. We call this formula a discriminant. A discriminant is equal to b squared minus 4ac. Okay, so when your discriminant, what does it tell you? A discriminant is saying that if you get you want to check how many solutions are going to have, are you going to have real solutions or no solutions at all? Your discriminant, if it's greater than 0, what do we mean? If you substitute your B, your A, and your C, you find that the value, it is positive. If your value is positive, it means you're going to get 2 real solutions. That means 2 x-intercepts. That means your thing is going to be doing this. Okay, it means you're going to have 2 x-intercepts if your discriminant is greater than 0. If your discriminant is equal to 0, okay, it means you are going to have 1 real solution. That means there's only going to be 1 real solution. So your graph is going to be looking like this. It's going to be touching at least 1 point. Okay, that's when your discriminant is is equal to 0. When your discriminant is less than 0, it means you are not going to have any solutions. What do we mean by that? We mean your thing is not going to be touching your x-axis. It means your thing is going to be flying there. Okay, so it is not intercepting your x-axis. Remember, this is your x-axis, this is your y-axis. So it is important for you to know these terms. This is a terminology. Those are the critical aspects about a standard form when it's written in this form. Okay, and then we've got another form. Another form of a quadratic is the one that is called a vertex form. So there is a vertex form. A vertex form is when you've got a quadratic equation which looks like this. This is a into x minus h to the power squared plus k. Sometimes you can get the quadratic equation in this form. You can get the properties of your quadratic here. This thing, what it tells us is you can get the coordinates of your turning point. I'm going to put TP for my turning points. The things for your turning point, you only take this, which is your H and also your K. So you don't have to go and calculate your turning point. You can easily get your turning points. Okay, and then what else does this suggest? It also gives us information about the axis of symmetry. Okay, so the axis of symmetry is when your x is equal to h. So this one, if you take this thing and equate it to 0, you will get your axis of symmetry. So that's about it. The vertex form, when you given this your quadratic equation in this form, you only get two information. One is a turning point, one is your axis of symmetry. Be careful. Your k does not represent your y-intercept. Okay, so don't make that misconception and think this also represent the turning point. No, it is a y coordinate of your turning point. Okay, what is another form? You've got another form which we call an intercept form. Okay, an intercept form is in a form y is equal to a into x minus x1 into x minus x2. Okay, so this is an intercept form. Sometimes you'd find your quadratic in this form. What information does it suggest to you? It is giving you the x-intercepts. That's the first thing that it gives you. That's what makes it unique. So it's giving you the x-intercepts. Your x-intercept will be your x1 and your x2. Okay, so now this value is going to be for your x-intercept, and this value is going to be your another x-intercept. Why it's important for you to know the three different forms is for you to know, if I'm given x-intercepts only, how can I use the standard form to get the standard another standard form? You can translate between the three different forms, but your module, you are not expected to reproduce this like this one. Okay, this one you can get from this one. You can translate from the standard form to this one. We use a method which is called completing a square, but we are not going to do that. It's not for our expectations at this level, whereby we go and reproduce this one. But you can get this form from this form. Okay, just be aware. So what I've done here is to present to you the different forms of a quadratic. So now what is left for us now is to say, okay, fine, why should we care? Okay, you should care because this is your toolbox. Okay, so now what we need to do, because now you've got your toolbox, these are the critical aspects. What do you do with these critical aspects? You go and apply them in problem solving. So we are going to be attending to different examples, so then we can see the strategy and the procedure of solving these. Okay, here's one example that I found. Okay, this example, you are given a quadratic. We know it's a quadratic, we are told. This is a quadratic thing. It is given in this form. At the same time, information is also given in a quadratic. Let's analyze the given information. It's always important to analyze what is given. Okay, what is given? You are given the turning points. Okay, your turning points, the coordinates of your turning points, it is -2, comma 10. That is your turning point. And we also know the axis of symmetry, your x is equal to -2. And what else do we know? We also know what is our y-intercept. There is our y-intercept. So our y-intercept is equal to 6. Okay, we can see, ne? We can see our y-intercept. Okay, we can see the x-intercept, but now it's difficult for us to see because they are not whole numbers like about 1, 2, 3, 4, 5. But we can see. But what is it that you can tell about this? If you were to go back to our analysis of the discriminant, if ever we said if ever your discriminant is greater than 0, it means now you are going to have 2 intercepts. This thing has got 2 x-intercept. It means your discriminant is greater than 0. That means it is positive. So you are just giving you an idea of what is happening here. You're doing what you call, you are doing it's a global approach. You're analyzing the information that is given to you. And then once you've got an idea of the information that is suggested by your graph and what is given, you can come in now and try and attend to the questions. The one question is saying, which one of the following is true? We are looking for the truth, okay? The value of the y at the turning point is negative. Okay, because you've already done your analysis of what is given to you. You have done a global approach, a global analysis. You can easily tell, Banamanga, my y-intercept is positive. There it is equal to 10. So this one is not true. We're looking at something that is true. Yeah. And then they say the value, the value of the x of the vertex. Remember, the vertex is your x value of your turning point. Okay, it is the axis of symmetry. Your axis of symmetry will be this line. It is the x coordinate of your turning point. We've already identified that it is negative, and then Bonabati is positive. You can easily come because you've done your analysis already. Okay, the value of A is negative. Okay, from our analysis, we know if ever this thing is frowning, it's a frowning face, it is looking down. If your graph is looking down, it means your A is less than 0. That means it is negative. Okay, this is true. From all this information, you are getting it from your toolbox. And then the discriminant is negative. Okay, most definitely it is not negative because remember from our analysis we said from our toolbox we know we've got 2 real solutions. This thing is intercepting. When your things are intercepting your x-axis at 2 points, it means your discriminant is greater than 0. This is from your toolbox. So therefore this is lie. This is lie. None of above. It does not really matter. So your correct solution will be equal to this one. Without doing any calculation, just from your analysis. So it is important to first do your global approach analysis. Every time, it does not matter what kind of situation that you are in. Okay, here's another one. This one is saying, okay, this one we are saying here, here we are told we've got a quadratic function, okay, which is in this form. We are asked to find the discriminant. This is in a form a x squared plus bx plus c. Okay, we know what is our discriminant. Our discriminant is your discriminant is equal to b squared minus 4ac. This is coming from your toolbox. So what is your b? Your b is negative 15. Okay, your b is negative 15 all squared, and then minus 4. What is your a? Your a is 4, and then what is your c? Your c is equal to 10. Okay, so look at your B. Your B is a negative number. It's not just 15. Negative number is a notorious number that you must always handle with care. Okay, so don't just take only the number, also take the sign of that number, that is negative 15. So you can just plug this thing into your calculator, which is going to give you 65. So if your discriminant is greater than 0, this is greater than 0, then you know this thing has got two real solutions. It means you can go and find the solution of here, the x-intercept. Either you can use the formula or you can factorize. It will depend on the situation that you are in. Okay. So question 3, this is what this thing is suggesting. This is a quadratic form. You are told that this thing can be rewritten as y is equal to ax squared plus c, where the values of a, b, c. So you need to simplify. There's nothing that you need to do here other than simplifying. Okay. So to simplify, you're going to have your y minus 6 is equal to 3 into, and now we need to simplify here. Okay. I hope the masses know how to how to simplify here. We are going to use the distributive property, or there's that method. Is it LIFO or FIFO? I don't know what it's called, but we are going to start by the first terms. The first terms is equal to x squared. The inner terms, it is minus 2x. The outer term, it is x minus 1. Which is minus x. The last terms, that is negative 2 multiplied by negative 1, is going to be positive 2. If, guys, you think, hey, I don't know, I forgot, I forgot how to do this thing, that means you've got a reason to book a consultation with me, so then I can take you through on how to do basic distributive property. So this is going to be equal to 3x squared. Okay, before doing that, let us simplify. It's always good to do these things step by step. So this is x squared minus 3x plus 2, y minus 6. So this is going to be equal to 3x squared minus 9x plus 6. I'm going to take that 6 that side, which is going to be equal to 6. So this is going to be equal to 3x squared minus 9x plus utwalufa. Okay, so I've got my thing there. So I know my A is equal to 3, my B is equal to -9, my C is equal to 12. Okay, so that means this is your answer. So what was important here is for us to be able to simplify our equation. Okay, here's another one. The turning point, we need to find a turning point here. Okay, the turning point of this thing is equal to this. So remember, for us to find a turning point, we first look for the axis of symmetry, and the axis of symmetry, you've got your x is equal to minus b over 2a. Okay, you know that your a is equal to 2, your b is equal to 3, your c is equal to -4. Okay, so you can just come and substitute here. Your b is -3 over 2 multiplied by 2. This is going to be equal to -3 over 4. Okay, so this is only the x coordinate of your turning point. To find the y coordinate, you need to take this value and substitute it into your original equation. So you're going to have your y is equal to 2 into -3 over 4 all squared plus 3 -3 over 4 minus 4. Okay, so through the simplification, I'm not going to go through a simplification, guys. Through the simplification, you'll find that you get -41 over 8, which implies that this is equal to, because now if you look here, you've got your x coordinate. It is -3/4. There is your -3/4, but you need to get your x coordinate, your y coordinate. So to get your y coordinate, it means now you need to, this one looks like a mixed fraction. So you need to attempt to write this thing as a mixed fraction. You say 8 goes how many times to 41? It goes 5 times. And what are you going to be left with? You're going to be left with 1/8. Okay? So now you can see, Guti, this is your turning point. All right? So it can look simpler to those who don't have problem with quadratic. Not all of us, we remember these things, guys. Okay? We don't remember these things. So that's why we take you through this. Okay? So here's another one. Consider a quadratic equation, which is this one. The x-intercepts are, okay? So we need to find the x-intercepts. Remember, what is the formula for x-intercepts? It is x is equal to minus b. We've got x is equal to minus b plus or minus b squared minus 4ac divided by 2a. Okay? That is the formula for our x-intercept. So here you know that your a is equal to -3. You know that your b is equal to 5. You know that your c is equal to 7. It's always good to take these values out of your equation. So once you are done there, what you need to do now is to find your to get these things into your formula. So what is your b? Your b is 5, so you're going to have -5 plus or minus into, what is your b? Your b is 5 squared minus 4. What is your a? Is -3. What is your c? It is 7. And then you divide that by 2. What is your a? Your a is -3. The signs is very important, how you work with your signs. Okay, so now this is going to be equal to -5. You're always looking at the choice of your answers. Plus or minus 25. Okay, 25 plus 84 divided by -6. So this is equal to -5 plus or minus 109. Able? Or someone is talking, exciting. So now you look at this, okay? Look, if ever you've got something that looks like that, then you can see Guti Nance. Okay? It is just to know your toolbox. Once you know your toolbox, you can do anything with functions. Okay? Here's another one. Okay? In here, you are given, just by looking at this thing, I can analyze this thing, Mina, sitting here. Okay, I've got a quadratic equation. This is a quadratic equation. And then what can I, if I'm relating this is a symbolic form, this is a graphical form. From here, I know this is equal to y is equal to a x squared plus bc, bx plus c. I know what is my y-intercept. My y-intercept is -3. So I know le b lona -3. I can just tell. I've not answered any question, but I can tell lona is -3, and then and also I can also find, okay, I can also find my my a coordinate using the formula. At least I am happy with that. So without going and waste time and calculating things. So this is what I know, and I know what my discriminant here is greater than 0, because this thing is touching this thing at 2 points, and I know what if value a is equal to 1, I can see, and this thing is smiling. It's a smiling face. Let me go and answer the questions from the information that I've gathered from my toolbox. So the determinants of a is for the turning point. That means here I need my my x of symmetry. So I'm going to have x is equal to minus b over 2a. Okay, so here I know that my a is equal to 1, my b is equal to -2, my c is equal to -3. Okay, so now this is going to be equal to negative, -2. I always like to protect my negative numbers because, hey, they can bias you. So make sure that you protect them. That's why I'm putting the negative number. So this is 1, okay? So this implies that this is going to negative multiplied by negative is positive. I've got 2 over 2 multiplied by 2 is 2. So my x coordinate is equal to 1. Okay, same procedure. How do I find the y coordinate? I need to take this one and substitute it into my equation. Okay, so my y is equal to, my x is 1. You've got 1 to the power 2 minus 2 into 1 minus 3. Okay, this is equal to 1. 1 minus 2 minus 3. So this is simply equal to, is it minus 4? 3, 4, 5 is minus 4. So my TP is 1 comma minus 4. Okay, which is simply equal to this one. Okay, so you can see how you calculate the turning point. The process is almost is the same, not almost the same. Calculate the coordinates of C and D. Okay, the coordinates of C and D. The coordinates of C and D, these are the x-intercepts. Okay, so now to get my x-intercept, I need to get my equation. Okay, my equation is y is equal to x squared minus 2x minus 3. Remember, you've got 2 options of getting your x-intercept. Either you use a formula, x is equal to minus b plus or minus x is equal to, you can use this one, x is equal to minus b plus or minus so this is equal to b squared minus 4ac divided by, I mean, if you're struggling with Lento, guys, you think you are struggling with your factorization, you can use this formula. It's not a problem. But Mina, I can easily factorize this thing by inspection. Just by looking at this, I know into Guti, I'm looking for the factors of 3. When I subtract them, I'm going to get to 2, just by inspection. Then I know Guti, I can easily factorize without using this formula. This formula is for when you don't, it's difficult to find the factors. But this one, I can get just by inspection. I can get into Guti, I am looking for the factors of 3. When I subtract them, I get 2. That is 3 and 1. And then I'm going to give the bigger number a sign of the middle number. That means this one is going to get negative. This one is going to get positive. Okay, so I know what are my x coordinates. So from here, remember what we said when we had that intercept method. An intercept method is saying that for your x-intercept, because you're looking for an x-intercept, remember, for your x-intercept, you let your y to be equal to 0. So I'm going to let my y to be equal to 0. So I'm going to have x minus 3 into x plus 1. Okay, for me to simplify here, I'm going to use this property, which is saying if you've got AB is equal to 0, your A is equal to 0, or your B is equal to 0. This is a property that you find Lapagua mathematics. So here, I'm going to say my x minus 3 is equal to, my x minus 3 is equal to 0, or my x plus 1 is equal to 0. So therefore, my x is equal to 3, or my x is equal to minus 1. Those are my x coordinates. So now how do I write this thing? Remember, we said for your x-intercept, you let your y to be 0. Remember from yesterday, we said your x-intercepts, you are writing them in this form. Okay, so here 1 is going to be x comma 0. We are writing it in a coordinate form, or this one is minus 1 comma 0. Okay, so now we are looking for what is your x here? Your x is 3. Your x is 3, so I'm looking for 3, 0. There is your 3, 0 and minus 1, 0. There it is. So these are your coordinates. Okay. So that's one way. If you don't know how to factorize a simply algebraic expression, use this one. It will get you to this. Does not matter, but it's a longer way. So you need to be economical with your time. Only use a formula if ever you cannot get ELAND. Okay. So this is what I got from my things somewhere, just to pull everything together now. Okay. This question is helping us to pull everything together, the linear functions together with the quadratic function, and see them in one Cartesian plane. Okay, so now first thing, remember, before you do anything, look at what you are given. Okay, you are given all this information. You are given a formula. You are told go to your G is a straight line. You can see it's a straight line, and you are also given point A is equal to -2, 4. Let us just play around with this and see if ever we cannot fill in any gaps. So we know Guti point D, it is equal to 6. This one is 6. Based on this is easily, I can tell. And then the x-intercepts, one thing that you can analyze about this, your x-intercepts of your quadratic, there's 2 of them because it's a discriminant. This thing is telling us about the discriminant. Okay, the discriminant is greater than 0 because you've got 2 x-intercept and your A is negative. You can tell because this thing is telling you, and it's also together with your graph is showing you. So now we need to determine the x-intercept of your f. Your f is this one. We need to get the x-intercepts. So how do you get the x-intercepts? You've got your f of x is equal to negative x squared minus x plus 6. If you don't like f or x, so uyakuphazamisa in your thinking. This is just equal y is equal to negative x squared minus x plus 6. You want to get x-intercept. Remember, to get your x-intercept, you let your y to be equal to 0. So this is equal to 0 is equal to negative x squared minus x plus 6. If you don't know how to factorize, use your formula. X is equal to minus b plus or minus square root of b squared minus 4ac. So here we can say this is x squared plus x minus 6 is equal to 0. This is a quadratic equation that we can factorize. So we are looking for factors of 6. When we subtract them, we are going to get 1. Okay, that is 3 and 2. 3 multiplied by 2 is 6. 3 minus 2, it is 1. So I can easily get my things here. So this is going to be equal to x and x. So this is 3. This is 2. It's going to be plus. This is minus. So your x plus 3 is equal to 0, or your x minus 2 is equal to 0. Therefore, your x is minus 3, or your x is equal to 2. Those are your x-intercepts. We are going to go and substitute this thing into our graph. So now this, because it's on you've got 0 on the negative side. Your B, this one is -3. Your C is equal to 2. Okay, you've got that one. They say write down the equation of your axis of symmetry. We know the axis of symmetry, it is x is equal to minus b over 2a. Okay, so now what do we do? We know from here, this is the equation that you are working with, your original equation. Okay, so here we know that our A is equal to -1, our B is equal to -1, our C is equal to 6. So that's what we know. So now you take that to substitute here. So this implies that your B is minus, so it's minus 1 divided by 2. Your A is minus 1. So this is going to be equal to 1 over negative 2. So now your x of symmetry, okay? So we are looking for equation of x of symmetry. The equation of x of symmetry is x is equal to something. So here, this is negative half, okay? This is negative half. It's your x of symmetry is where you get your x coordinate. And then I'm not going to be talking about the range. Okay, I don't want to talk about the range. Is your graph is running. Your graph is your values is minus 3 going to all the values. Your x is less than negative 3. That will be your range. I'm not going to be talking about that because it's not for our terminology that you are using at this level. So your graph can run all the way, picking up all the negative values. Okay, all the negative values of your y. It can go on and on and on and on. So now what you can say here is your range is all the values is from here. Oh, this is the domain. I'm talking about the domain. This is a domain whereby your x is greater than is less than negative 3 for all the negative values. And then from here, this thing will run all the way where your x values are greater than 2. So now it is taking all this and then taking also the values between these two. So I don't want us to talk about the domain and the range. It's for another topic. What I wanted us to do is to pull together the equations, the linear equation and the quadratic form using our toolboxes. So now we need to write down the equation of a linear equation. How can we calculate the equation of a linear function? Go back to your diagram. Okay, a linear function is this one. We're born a linear function. Linear function, we've already written all of the coordinates. So we know our linear function is in this form. Your y is equal to mx plus uc. What do you know about the given information? I know what is my y-intercept. So I already know what is my c? My c is 6, so I've got mx plus 6. Okay, what else do I need? I need to get your gradient. How can I get my gradient? Okay, if you've got time, guys, you can go and calculate your gradient. If ever you cannot, you don't know any other method, you can get the gradient because you've got two coordinates here, and go and calculate the gradient and use the formula m is equal to y2 minus y1 over x2 minus x1, because you have this coordinate, you've got this coordinate, you can go and calculate your gradient, but you don't have to do that. You need to be economical about your time. So now what you can do here is to say, my line, this is this line. This line, it is this one. This line there, it is crossing at this point and also crossing at that point. Okay, I've already used this point because it is this one. I have another point that I can use. So I'm going to name this point my x, and then this one is going to be equal to my y, and take the x value and substitute it here and my y value, so then I can get my m. Okay, so let's do that. You're going to have 4 is equal to m, what is my x? Is minus 2 plus 6. Okay, so this is going to be equal to 4 is equal to negative 2m plus 6. Okay, so negative 2m is equal to 6 minus 4. So my 2m is equal to 6 minus 4 is equal to 2. So my gradient is just equal to 1. Okay, so now you've got your 1, so you go and substitute it here. So therefore, your equation of your straight line is y is equal to 1, which is going to be equal to 1x plus 6. We don't like to see a coefficient of 1. It looks so clumsy, so we just don't write 1. So you've got this. So this becomes the equation of your straight line. Okay? So a question can come in, okay, and ask you what are the points of intersection. That means you can get the values of -2 and this one by simultaneous equation. Remember, I took you through the simultaneous equation whereby we did elimination and substitution method. But if ever you're going to be combining these two, you would have to use a substitution method because you are using one form, which is a linear, and also the one which is a quadratic. So you cannot do an elimination, okay? It can become tricky, not that you can't, but the best way is to substitute. So now that's how you would be dealing with these two when we have pulled them together. And the people that have helped with a one-on-one, with the linear equations, you can easily see how we get the linear equations if ever you are given a point and a point and an intercept, or 2 points. Same procedure, same thinking. There's nothing more. And then write down the average gradient between A and D. Finding the average gradient, we are not there. A and D, to find the average gradient, it means we are finding this, okay? A change in Y and a change in X, okay? Which is the same as this one, which is equal to 1, okay? So we are not there. I just want to show you another example that I came across, which is pulling these things together. As an equation, same thinking. You are given a quadratic and also you are given a linear equation. Okay, so now you are given different points there. Okay, you are given your x-intercept. So now you've got this one, yeah? And then you've got this one. Okay, so you've got this, and then you've got that, and then you've got your t. Your t, you can see the coordinates. You are told what this is your, without saying a word, this is your y-intercept. So now this is your 8, okay, which is your range. Your range is running from 0 to 8. That is your range. And then, no, it is your y is less than 8. I'm not talking about the range today, but your range, it is this maximum point going down to the negative side, okay? So now your S is one of your x-intercept. Without even being told, you can see this is your x-intercept. And then your T, your y-intercept, your graph passes at ROT. So now that is the information that you are given. And then your A, you expect your A to be negative because this thing is frowning. What else do you know? Your discriminant is greater than or 0. That is an analysis that I'm just doing just by looking at the graph. And then what is the question? Okay. The diagram shows the graph. Okay, what was the question? I don't know what was the question asked because I don't have a question here. What was the question? I can help us to think about the question. We can find maybe a question can say, what is an equation of your linear equation? We can find this equation. Okay. You can find this equation. You've got your x-intercept, but now you don't have this one. So you'll be stuck here. If ever you are starting with y is equal to mx plus c. So now if you've got this one, the only information that you have here is equal to mx plus 8. Okay, so that's the information, the only information that you have. You don't know this one because you don't know the value of your x here. Okay, so now for you to find the value of your x, you would have to do what? What are the suggestions here? I don't know what is the question. I'm trying to gather the questions that can be asked here. Okay, so now I need to find my R and I need to find we are given this one. What is the value of our R? Can we find the value of our R? So these things are given in this form. Even your quadratic form is equal to y is equal to ax squared. Your q is just equal to 8. That's the only information that we have here, and we are stuck. We are stuck because I don't even know what was asked. I'm trying to find the equation. How do I find this equation? I can only use here. I don't know the question, guys. So I may have to abandon this question because I don't know the extra information that was given and what I'm supposed to find. But in any event, this is how you think about the quadratic. Ebo?
All right. And Kerry, you were saying we should find the equation for a straight line.
Mm.
Yes. I was thinking since what we have the turning point coordinates, we might use them, but then if we use them, let's say
Pardon?
you tell us that I was thinking if then we can use the t coordinates to find
To find?
the thing to find the linear equation.
Yeah.
Yes. And we
Uh,
can still use both of them to find the one for parabola.
okay, now this is where we are here. So we have used this one here.
Yes.
So what will be the next step to find the equation?
And get it already we know that 8 is our y-intercept.
Yeah.
Yes. And then we know that even if maybe let's start with the 1 year parabola.
Mm.
Yes, the 1 year parabola, let's substitute with the as coordinates, the 1 year 2 and 0.
Mm.
Yes. So meaning that if we substitute with those coordinates, our
For the
y is going
parabola.
to be 0, and then a it's 2 a2 squared plus, yes, on a parabola,
Yeah, you can find the equation of the parabola because you've got the
plus
turning
8.
point, and then you also have this one.
So 0 is, yeah, yes, but
Which
then
is we can say this is ax squared plus bx plus c. Okay, we already
yes,
know what is our c, which is our y-intercept, which is a, and then we can find the values of your a and the values of your
yes,
b. Okay, so now what will be those values?
yes.
What are those values?
Okay, now since well we are not given B.
Mm.
As you can see that as they say that the diagram shows the graph of g of x is equals to ax plus q, meaning that
Mm-hmm.
we only have a and c. We don't have b.
Mm.
Yes. So I was thinking probably we could substitute with the coordinates of s, whereas our y is going to be 0. A x is going to be replaced by 2 squared plus 8, and then it's going to be
What
0
is your 2?
my 2 is x.
Oh, here
Using s intercepts,
you say y is equal to
I'm saying until
is
we don't
0.
have b, yes,
Yeah,
0
yeah.
is equals to a into 2 squared, yes, plus 8, right?
Mm-hmm.
So first we have to calculate 2 squared, which is going to give
Plus
us
what?
4.
Plus 8.
Yes, plus 8.
Mm-hmm.
Okay, then it's going to be 0 is equals to 4a plus 8. And then we divide both sides by 4. So it's going to be 8 squared is equal to -2. So now we have our
quadratic.
Yes, that's our quadratic. And then when we do our straight line, we can use the t, but then if we use t, it surely tells us that we won't have a gradient.
But you can find, maybe you can find a point here. If you've got this one, this can give you another coordinate of your parabol. So then you can have this point. Then if you've got this point, you can easily get your gradient. Do you hear?
Okay.
If you take this one and let
Knowing
this
that
thing to be equal to 0,
yes, I can
your
hear
y,
you.
0 is
Meaning
equal
that
to
we can use
this one. This plus 8. Ne? So your 2x is equal to 8. So your x is equal to plus or minus 2. So now we know with this one, the x coordinate is -2 because it's on the negative side. So your r is -2. Okay, so now you've got two coordinates. You can go and find what we were looking for. We're looking for m. You can get your gradient because you've got 2 points. So to find your gradient, you're going to have your m is equal to y2 minus y1 over x2 minus x1. What is your y1? Decide on which one you're going to make your y1. Let's say it's this 8. So you're going to have your 8 minus this one is going to be
R1.
Pardon?
We can use t as our y2. We can use 8 as our y2.
Yes. Are you clear?
Can you hear me?
Yeah, I can.
Yes, we can use 8 as our y2 and 0 as our y1. Yes.
So your thing is going to be 0. This one is going to be 0 minus minus, which is plus 2. So this is going to be 8 divided by 2, which is equal to 4. So the gradient is equal to 4. So therefore, your y is equal to 4x plus 8. Okay. Okay. So this is a wrap.
Bye-bye.
Thank you so much. Bye.
Thank you. Bye-bye.
Thank you. Bye. Thank you.